Okay, so at this point, AirPods should be out, and cell phones need to physically be put down in your bags. Put that mental energy away that's in your phone, and then give me your mental energy up here for just a few minutes, and then we'll move to the practice assignment, okay? The day that I fixed that, I should have known, because I fixed it thinking, oh yeah, this is simple, no big deal. And
No, like, that's not what
oh. Oh, I know. Y'all need to calm down. Calm down, please. It's like the Taylor Swift song, just calm down. We're going to look at rotations. We're giving it a second day because yesterday all we did was clockwise. Now we're going to do counterclockwise. The good news is that if you understood clockwise, you will understand counterclockwise. This is what we did yesterday. We were rotating clockwise around the origin. We talked about how the only rotation we're going to do is around the origin, which is good because that means since the origin never moves, there are rules that we can apply, and we just follow the rules, find the new points, and plot them. We talked about clockwise is high noon and then going to the right. So counterclockwise would be high noon going to the left. Going to this page here, we're going to rotate counterclockwise around the origin still. Here are our rules. The origin is still 0, 0. That never moves. Because we're going counterclockwise, that is high noon and to the left. So that's me showing you the direction it's rotating, high noon and to the left. Look at the rules. They're very similar to the ones yesterday, but they're not the exact same for 90, 180, and 270 for all three of them. Look at the rules for these three, then flip your booklet, or actually don't even have to flip it. Shift your attention to the left and compare the rules from yesterday. Which rotation is the same rule?
180.
180. Why do you think the 180 clockwise and counterclockwise is the same rule? Keep thinking. Why would it, if I rotate clockwise?
Oh, it's the same spot.
There you go. So think about like skateboarders, snowboarders, BMX bikers. I'm trying to think of all the sports that would do it. When they do a 180, it means they're facing a direction, and it means that they now face the other direction, right? What? Or ice skaters, yeah. So I'm facing one direction. If I do a 180 turn, that means I'm now facing the completely opposite direction. Well, if I go clockwise, let's see, y'all are facing this way. So clockwise would be high noon to the right. So if I turn to the right, I land facing the back of the room. Now I'm going to start back over, facing the front. I'm going to go counterclockwise, high noon to the left. I'm still facing the back of the room. So regardless of which direction I turned, I ended up facing the same way at the end of the 180 degree turn, which is why the 180 degree rule is the same regardless of the direction you go. So if I give you a practice problem on 180, do you need to pay attention to the direction? Not really, right? The only time the direction matters is if it's 90 or 270. Does that make sense? Michaela, do you have this little booklet? Can you get it out for me?
Hey, do wake up.
Skylar, can you wake up and join me, if you don't mind? This booklet, we're on this booklet right here. You can get it out. So we're going to apply these rules. Remember that this little negative means sign change. And if you recall from yesterday, I said to do the sign change first and then swap the numbers if they do swap. Because then that way you don't accidentally change the sign of the wrong thing. So we're going to come right here just like yesterday. And we're going to write our new points. I would copy the rule above what you're doing. So your eyes are not having to look up at the top every time. Copy the rule. And then now I want you to apply the rule. So remember the way you read this, negative yx. This means change the sign of y and then bump the position to the other.
So when we change the sign of y, say y on the original figure is negative, would that change to a positive?
Yes. Yes. The negative in the formula means you can think of it two ways. You can think of it as change the sign, or you can think of it as, okay, so this is going to be a negative 2, which means it would be a positive. Yeah. Whatever the sign is of y, you would change it. And then, so this would be 3, negative 2. If I change the sign of y, I would have 3, 2. And then I want you to imagine the y picking up and shifting to the front. So I would have 2, 3. My next one, I've got 2, negative 5. Change the sign of y. Read it out loud in your head. So that's 2, 5. Pick the y up and shift it to the front. So that's 5, 2. Then I've got 5, negative 8. Change the sign of negative 8. That gives me positive 8. Pick it up, shift it to the front. So I've got 8, 5. Then I'd go graph it. So remember, first number is right or left, second number is up or down. So 2, 3, 5, 2, 8, 5. Now you're going to repeat the process with the rotation of 180. Remember, it's not a domino problem though, okay? So I want you to come back to the original pre-image. This is the original figure, the pre-image. You're going to rotate 180, which means, look at the rule, what do we do? This is what I would be testing over, is do you know how to read the rule and apply it? What do I do? What's this tell me to do? Change the sign of both of them, right? Now don't swap, just change sign. So A double prime, or we don't even have to label it, but A double prime would be negative 3, positive 2. See that? B double prime would be negative 2, positive 5. C double prime would be negative 5, positive 8. Then graph it. And And then now we're going to rotate to 70. Looking at the rule, which one gets the sign change? X, and then we're going to pick it up and shift it behind the Y so that it's Y, comma, negative X. So change the sign of X, imagine picking it up and shifting it behind it so that they'll be swapped. So this would be -2, -3, right? See how I do that? Change the sign of X to be -2. Imagine picking it up and putting it behind the -5. This would be -5. Pick it up, put it behind it. Yeah, Albert Einstein. In our transformations little flip book, the next page says rotating around a given point. We already talked about how the state removed this from our standards. So this is a nice to know. I am not taking it out of the flip book because I have a feeling it's coming back 1 year maybe. How far are we here? Actually, if you don't mind. So what page did we say that this would be? 37? Yeah, remember we're just gonna roll with it, and I'm gonna fix it, type it all up, and then copy it and give y'all a filled in one. So this is a nice to know. This is also a nice to know. This is the second one. Just to give you an idea, I'm not, again, nice to know. Don't write any of this down. You can put on there nice to know, so you'll wonder why we never did it. But when you're rotating around a point that's not the origin, it's still the same process. The difference is you can't apply a formula because the random point that you're rotating around moves, right? From problem to problem. So like this one is going around -1, -1. That's right here. So you would basically imagine taking this, your finger, your thumb, holding it down on the center of rotation, and imagine picking the A up and rotating, it says 90 counterclockwise. So 90 counterclockwise would be about like right there. Because that would form a 90-degree angle between my rotation. So this shape would land like over here somewhere, which would be weird because it's off-centered, right? It's not around the origin, it's around a random point. So that's what that used to look like, but we don't have to worry about that. This is the last stuff in your little flip book, and we are going to talk about this tomorrow, mapping. So you can keep the flip book out so that you have your rules of rotations. As you go to this paper right here. Yeah. So the very first problem, you might be thinking to yourself, I don't even know what I'm rotating because I don't see anything on the graph. There is a tiny little point right here, and it is a Y. They're asking you to simply rotate that point. Well, you've got your rules of rotations. Keep your little flip book out. If we're going 180, does direction matter? No, direction does not matter. The 180 rule, I kind of already have memorized. I'm not saying you need to memorize it, but you would look in your little booklet, you'd copy the rule, it's negative x, negative y, and so now you would apply the rule. The rule is negative x, negative y. This y value, this point, y, has the coordinates negative 5, positive 4. So y prime would become what? Positive 5, negative 4. And then I would graph it.
So we're
Making them up?
no, I'm talking
Sorry.
about the y.
Oh, it's here. If you look carefully, it's,
I
know.
did not see that.
It totally blends in, and when I made the assignment, I'm like, okay, I definitely had a problem there. What happened? Yeah, there's a point there. It just blends in. Now all the others are shapes, so you don't have to worry about trying to find what you're rotating. What did we say? 37. Let me look and see if there's any. So let's do 1 through 6, and then let's come together, and then we'll go to the back and